going to be about engineering the cutting edge. So everyone wants to make the next amazing thing in technology, and thankfully that's what Misty West is here to do. So my talk is focused primarily on how to organize your engineering team around this type of product design or engineering design. So my talk is going to have 4 main components. We're going to talk a bit about people, who do you look for and how do you organize them, the environment that you want to put these people in so that they can thrive, processes, things that you should watch out for in this type of hard engineering, problem-solving environment, things that are going to make your life a little bit easier as well, and the resources that you need to give your people so that they can make it happen. So yeah, to start, what is the cutting edge of tech? What does it really mean when we say that word? And in essence, the cutting edge of tech means 3 things to me that we're going to touch on throughout the presentation. The first is pushing a boundary of performance, cost, or time to delivery. So if, for example, you have something that exists, but you want to make something that performs way better than anything on the marketplace, we would consider that cutting edge tech. Or if you want to make a product in half the time, you're going to need a pretty together team to do it. It also includes creating a technology that straight up doesn't exist yet. You are the first one creating this new type of technology. And it can also include disrupting an existing market. So you're doing something that's been done before, but in a completely novel way. And of course, like Uber is a great example of this, and or Airbnb. Disrupting a market can be really cutting edge tech as well. So for a few examples of things that Misty West have done in terms of the cutting edge, this is a volumetric display. Intel hired us to create this technology. They had been working on it for about 3 years internally and couldn't create a functional prototype. So they came to us and we were able to create something for them in about 6 months. In essence, what it is a floating 3D image that you can move around and see without glasses. It's floating in midair. We also created an assembly that allows you to interact with this device using ultrasonic emitters, so you can actually feel the floating 3D image and interact with it. This is a technology that, as I mentioned, we created. It was first revealed at CES 2017, and it was demonstrated at the most recent SIGGRAPH. So, yeah, so as you can see, we were the team that actually created it. It was a very complex electromechanical assembly involving a lot of high-speed rotary equipment, which was a fun way for us to create some safety shielding and keep people away. And yeah, this is a project that we're really proud of. These are 2 of the main engineers, Dave and Derek, and this is our client Seth at CES demonstrating the volumetric display. So another example, this is what we consider pushing the edge of performance. We worked with a local company called Zoa to create a wearable particle counter. So in essence, you're walking around in the city, you don't really know the quality of the air that you're breathing. And wouldn't it be great if you had an app to tell you exactly whether the air you were breathing was harmful or not and to what degree. We were able to create this technology for Zoa. It is a laser optical particle detector. So it is a laser assembly that goes over a photodiode and is actually able to scatter light off those particles. The state-of-the-art technology at the time was about this big and $5,000. We were able to miniaturize it to this size and $250. So we consider that pushing the cutting edge of performance. And yeah, we created, I think 250 units functional for them to fulfill their Indiegogo run. The third is an example of cutting edge speed. So this is a novel brewing technology from a company called Alpha Da Vinci. In essence, what they wanted to do is you put all of the coffee in the top batch, about 1 liter, and at the precise moment that the brew is perfectly done, you vacuum siphon it through to the lower one. So you have perfectly extracted 1 liter of coffee. They came to us with an industrial design concept, no functional prototype yet. We were able to turn it into this conference floor functional demonstration in 6 weeks. So if you go to the next slide, you can see like it's a complex assembly, a lot of fluidics, everything had to be food safe, everything had to be stainless steel, and we were able to get it done. So yeah, why Misty West? Why is some small team from Vancouver, Canada able to solve all of these hard problems? And this is our team. We're 30 people now. As you can see, we're at that stage where it's kind of hard to get everyone in the same place at the same time, but we're still small enough that we can fit on a single staircase, which is nice. We are an integrated technology team, so we have electrical engineers, mechanical engineers, industrial designers, firmware people, all the way to beginning software, but not a lot of software. But we keep all of those skills in-house, and we work very closely together on our prototypes. And these are some of our collaborators. On the bottom are a lot of startups that come to us because they don't have their own engineering team. And at the top, you see that there are a lot of big-name firms that everybody recognizes. These firms come to us when they have a problem that they can't solve. And these are some of the verticals that we are working in. I won't spend too much time here, but machine learning, Internet of Things, a lot of Bluetooth stuff, mostly hard problems that are complex in nature is what we focus on. And why am I the one here talking to you? So I'm a mechanical designer. I've been with Misty West since 2012. I was employee number 6. I've worked on over 30 projects with the company in a capacity of mostly mechanical design and project management. Some of my specialties are microfluidics, medical devices, and industrial energy. So, back to hard problems. Let's start with people. So these are the people who are actually going to get the work done. And who does Misty West look for when we are looking to hire? First, we want multidisciplinary people. So, multidisciplinary people can include people who have a dual degree, like people who have more than one degree in fairly different disciplines, but usually kind of similar, like computer science and electrical engineering, or mechanical and physics. We also look for people who have very different but involved hobbies. For example, this is Derek. He is an engineering physics mechanical discipline, but he is also a sweet DJ. He DJs a lot of our events. He's very invested in music, and he's very passionate about music, and we recognize that this type of multidisciplinary behavior, it allows you to step outside your comfort zone. When you become too siloed in a single particular area, you can be really reluctant to step outside your field of expertise. We also find that multidisciplinary people are more comfortable, pushing outside their area of expertise, and also you did great. They're also able to translate concepts. So quite often, a lot of our breakthroughs come from experience in one field of technology and recognizing that that field, that technique, could apply to a completely different technology or area of technology. And multidisciplinary people are the type of people who will recognize that. We also rely on them as switch hitters. So quite often in a consultancy, we don't know what our project is going to be, and multidisciplinary people are a lot more flexible. And when you're building a small team, that can be essential. Next, first principles focus. So first principles means going back to the root equations of physics, math. This is Kevin Robbie. He was a tenured engineering physics professor, and we invited him to come work to us. And here he is building a demonstration of using CO2 to cool something. And because he had this depth of first principles, he was able to understand very clearly what the cooling capacity of CO2 should be. And this type of first principles thinking is something that we apply to all of our projects. No matter what we're doing, we try to take it back to the root of physics and what is the real problem that we're trying to solve, and what are the thresholds of how we will be able to solve it. So a first principles focus will let you push those technological boundaries. Next, weird tolerance. So, we don't necessarily look for weird people. I'm not going to say specifically whether anyone in the US is weird, but having a weird tolerance is something that we have recognized is really important. And this is because, again, we are invested in the cutting edge of tech. We want people to push outside the boundaries of the known. And being comfortable going into a place where you're not super sure it's going to work out, you're not super sure what's going on, but you can be chill. It's like, let's go, let's figure out what's happening. That is proven to be pretty essential to building to work towards something that has never been done. Next, a sense of humor. This is another thing that we've identified early on as being really, really important. And it's taken us a while to understand why that is. Misty West, even though we're working all the time on really challenging, really stressful technology on really tight timelines, you'll hear a lot of laughter in our office. These are two photos. So on the right is Erin. This is a photo that was taken during the build of Alpha Da Vinci. As I said, that was that 6-week tight turn thing. We still found time to goof around. And this is Justin. We're working on a medical device that is going to help diagnose a disease that affects children worldwide. But, you know, like, there's still time to goof off with the prototypes. What I think we have discovered is that a little bit of levity helps you get through a really difficult situation. When you're in a really stressful situation, you're dealing with the unknown, you're dealing with a lot of like imposter syndrome and your own personal limitations, a sense of humor can help you get through. So, a sense of humor, we have decided, helps keep the team together when things get difficult. And this team cohesion is really what helps us push through. Next, hands-on experience. This is super, super critical. Hands-on experience allows people to take things from theory land to real land. If you've ever built something, you know it's harder than you think it's going to be every single time, and sometimes you encounter a barrier, and you're like, oh man, the whole project is wrong. If you have experience building real things, you know that you're going to be able to navigate those types of challenges. For example, this is Justin doing some hands-on assembly work for us. What attracted us to him initially is when he was an intern, he had built his own bamboo bicycle from scratch and had gotten featured on Instructables. So this is why we knew Justin was one of the people we absolutely had to hire. So building hands-on, it helps people work through the problems in order to create something that actually exists. Finally, passion for your end goal. Whatever your company whatever your company product is oriented around, the people that you hire should be equally passionate about the problem that you're trying to solve with your technology. So for example, in a broad perspective, Misty West focuses on high impact projects that we believe are going to make the world more awesome. We focus a lot on sustainability, medical devices, cutting edge tech. And we hire people who are super passionate about making the world a better place. Zenny is here with us today, and she also went down to San Francisco to demonstrate a medical device that we were doing, and her passion led her through to getting first place at the science fair. But yeah, the people who are passionate for the goal that you're trying to solve, again, when they encounter barriers, that passion will motivate them to push through that difficulty and get through to that hard problem. So on a final note for this section, we consider our suppliers to be part of our team. We work very closely with the people who actually fab stuff for us. It's not just a job, right? We build those relationships. We work very closely with these people. So this is Dave at our manufacturing facility, UChoice, which is in Vancouver. But we go there often to discuss with them the problems that we're having because our boards are really weird and difficult sometimes. We also recently, our trip to Shenzhen this year was visiting the people who make the actual printed circuit boards here in Shenzhen to get to know them better, to discuss how we can improve our process to make life easier for them. We are constantly trying to improve that. And finally, your clients are your partners too. You're not always going to be in a client-facing business necessarily in tech, so consulting is a little bit different from that. But we are about as selective of our clients as we are of our employees. We've come to realize that reasonableness is pretty important when you're dealing with a really difficult technical problem. We're looking for people who are reasonable in their expectations, reasonable when they encounter difficulty, and we can work together. Communication skills is also pretty important. So these were our clients for the Alpha Da Vinci project, and as you can see, they flew up from Salt Lake to come and deal with the actual technical issues as they were happening because they were that invested in the goal. Their passion drove our passion. So to recap, when you're looking for people, If you're looking for solving hard problems, we recommend multidisciplinary people, people who have a good first principles basis to their understanding of engineering, have a weird tolerance, have a good sense of humor, have some hands-on experience, and passion for the goal of whatever you're trying to solve. So next, as we go through our 4 elements, is the environment. So, as I've mentioned earlier, our organization is based in Vancouver, Canada, which is a weird place to have a hardware consultancy, to be honest. But we do consider that Vancouver is part of our secret sauce. And I'd like to illustrate a few points as to why we think that is. So to give you a bit of background, sorry, since I need a little bit back. To give you a bit of background, Vancouver is Canada's 3rd largest city. Has anyone ever been? Yeah, nice. It's a nice place. 2.4 million people, pretty small compared to a lot of cities over here. And it's a Canadian city, which has a pretty big impact on your day-to-day life. Pretty stable government, good democracy, good infrastructure, high taxes, but for good reason. And these are where our clients are based. So I wanted to put this slide up to just kind of do the caveat that this is a very North American-focused presentation, so your mileage may vary. A lot of our clientele.
What is it?
I think way out on the West Coast. Very inconvenient to fly anywhere. But our clients, as you can see, are all over. We've worked with Texas, California, Utah, Boston, all the way up in Alaska. We're looking to expand all the time, but so far our clients have largely been in North America. These are the Misty Mountains, after which we are named. Vancouver is a city with a very strong environmental focus. And because we were building a consultancy with a strong environmental focus, we tend to attract people who are aligned with that. Being outdoorsy is a pretty big part of being a Vancouverite. This is the view from the Chief, which is a very popular hike. This is Steve the dog, our famous dog, out on a hike of his own. And it is also a very multicultural city. So it is a city that celebrates differences. These are a few of the common events. So we have our Chinese New Year, which as you can see is huge, our Lunar New Year celebration. Pride, which attracts about 50,000 people. This is a First Nations demonstration, and this is, I think, Diwali. But all of these different groups are celebrated within Vancouver. It's highly multicultural, and you'll meet people from everywhere, every single day. It's not something we always get right. We are always working to improve, but it's something that I like to think we have a lot of opportunity to improve, because there are so many people from so many different places. And MistyWest tries to reflect this in the way that we run our company. We want people to be able to bring their whole selves to work. And so we are all different, but we work together, and that is part of our city ethos and part of our company ethos. So next, if you have all these cool people in this cool place, what about your company? How do you structure your company to achieve peak performance? This is, the last slide was Powder Day, Powder before profit, so we closed the whole office and went up to the hill. So a couple of points. The first thing we try to enforce in our policy is the common goal over personal ego. So everyone is on the same team. Everyone is working towards the goal we're trying to solve. Even if it is your project or your idea or your discipline, it's more important to work towards the common goal together. So an example of this, this is what we call our Snow in California goal. This was a project that we were doing for CES, which is in January every year. One engineer was responsible for this entire design, but he ordered his parts in time, and they were going to ship right in time for him to be able to assemble it very smoothly. It was going to be great, and then ship it off to Vegas for CES. But unfortunately, there was snow in California. There was like 1 centimeter of snow, and that shut the entire highway down, which of course we think is hilarious. But it wasn't super hilarious at the time. And so the 3 of us, this photo was taken at 3 in the morning. None of us were on this project, but we all rallied together to get the parts built because the common goal was way more important than the fact that this one engineer, had some bad luck. invested on the common goal, we can put our differences aside and work together. The problem is more important. Let's all solve the problem. So next, support individual learning. This is a photo of Electronic Club. This is Cinzeni and Andreas. Yeah! We started Electronics Club because we wanted to learn more about electronics. Cinzeni is a biomedical engineer and I'm a mech. So we don't actually know a lot of electronics compared to our electromechanical senior engineers, but we wanted to understand them better. But supporting individual learning is something that Misty West considers really important to our success, especially within the context of a project. So when we are choosing the resources for what we apply, who we decide to apply to each project, we keep the individual's learning goals in mind. We find that when an individual is still learning in their process, they take a step back. They're a little bit more thorough. They're less likely to make mistakes, ironically, because they're less likely to breeze through what they're doing. They're also much more motivated because they are learning for themselves, and that is improving their career. If you spend any time working with engineers, you know that this is critical to retention. Good engineers will stick around as long as they feel like they are still learning. The last point is when it's difficult, they will push through. So yeah, I think it's okay. Oh, sorry. Yeah. The final thing is that they will bring a new perspective. So we try to broaden everyone's perspective, and if they have experience in a broader field, they're more likely to catch problems before they become difficult. So next, every role is equally important. Whether you are the senior engineer, the one with 15 years of experience in 10-layer boards or whatever, or you are the person who is getting payroll together, every single role at Misty West is towards the goal of making the world a better place. And we enforce that every single role needs to be respected equally. When that happens, you also allow people to trust each other more. So when I trust that you're going to do the most amazing job you can, and you trust that they're going to do the most amazing job you can, it frees you, right? It frees you to focus on your part of the problem. And that is how we work together as a team to really break through these hard technical problems. So when everyone is respected, they will rely on each other. And this is really important when you're creating something new. Next, communicate risks. So in our culture, at least in North American culture, there is a very heavy emphasis on a can-do attitude. You know, if you ask me, like, can I create a hologram? I have to say, yes, sir, absolutely, right? You better believe it. But actually, in Misty West, we encourage the opposite. We want to talk continuously about why this can't be done. What are the risks along the way? What should we watch out for? And we try to communicate that openly and continuously so that we can build in contingencies, right? We can find a problem before it becomes a deal breaker for the client. So always be communicating risks. When we are open about it, we can focus on solutions. Again, like rather than personal ego of being like super confident or whatever, it's about the problem, it's about the goal. Number 5, failure is normal and okay. So when you are working on cutting edge technology, you should actually be expecting to encounter failure a lot. We fail over and over and over again until we succeed. And we try to encourage that mentality in our employees. Like when we get our parts, let's put it together and see how it doesn't work. Rather than to expect that it will work perfectly the first time. And we also really encourage a blameless culture, right? Whenever someone encounters a problem, it's not their screw up. It is a problem for the team. And we are going to work together to overcome it. So failure is, it's important for people to feel safe to fail, and that will encourage them to take more chances. When we're trying to get breakthrough technologies, they have to feel confident that they can try something that might not work, and their colleagues won't, break them over the coals for it. And related to this, vulnerability is okay. It's actually pretty ironic that a lot of what we do at Misty West is talking about feelings. I think this is something that new engineers have to get used to. We spend a lot of time talking about imposter syndrome and dealing with engineers' anxieties because, we're very trained to be perfect We're trained to always succeed, to never fail. And so to overcome that kind of cultural training of being like, we need to create something new, and so we have to be used to facing fear. And this also allows employees to push through their own personal comfort zone, to face their own fears, to be even better than they think they could have been. So, people who are safe to feel vulnerable can actually push their own limits of achievement. So to review, the environment that makes people succeed for hard technical problems is investing in the common goal over the personal ego, supporting individual learning goals, making sure that everyone on the team is respected, communicating risks constantly, building the expectation that you're going to fail, and making sure that that's okay. You know, it's okay to face your fears together. So next, we're going to talk about resources. What do you need to give this team in order to make sure that they can succeed? I mean, you can put a bunch of engineers in a nice field, but you're going to need to give them a few things. So the three categories I'd like to talk about are technology, team, and time. So to start with is technology. And you might expect that, we would use a lot of cutting-edge technology, but actually at Misty West, we go with the reverse. We rely on technology that we can trust, so that we can focus on the core problem we're trying to work on. So a good example of this is 3D printing. 3D printing is pretty hot. You would expect that we use a ton of this, and we do use it, but quite often if you're doing something complicated, if you've ever owned a 3D printer, you'll be familiar with this. You have to spend so much time dealing with print failures. You have to deal with warp. You know, you have to deal with your material not being quite right. And solving these problems can feel productive in that, like, oh yeah, I got it within a 0.01 thou tolerance, right? But it took you like six hours to get there. But if you had used a more trusted, more old school technology, you'd be able to get it right the first time. And you'd be able to have the confidence that you're going to get your parts back well. So at Misty West, we actually really rely on tight turn CNC. But when we do use 3D printing, we actually try to take a lot of this old school learning and apply it to new school tech. This is a technique that one of our senior mechanicals created. I was really impressed with it. This is an SLA printed part, and these parts are quite small. And if you've ever gotten SLA 3D printing, you know you pay for setup per part. And if it's quite small, sometimes it can get knocked over and not be perfect. So we created this, he borrowed from injection molding tooling. If you've ever built a model kit, you'd be familiar with this. You bind everything together with all of these gates and screws. Just applied that technology to 3D printing. Yeah, that's cool, right?
I do that too.
Oh, you do it? Sweet. Yeah, this is a great technique. And it allows you to batch small parts and get them really low cost. So we rely on this kind of old and new blend all the time. This is an example of laser cutting going back to this Alpha Da Vinci project that we turned in 6 weeks. We have a lot of problems to solve during that 6-week time period. But one thing that we knew we could count on is that we could get laser cutting in a day, which in Vancouver is pretty good. Like, it's not Shenzhen fast, but you do what you can in Vancouver. We know that you can get hole cut super accurately. We know that it's super fast to design. So we didn't have to worry about this too much. If there was a problem with the laser cut part, you could just drill a hole in it. That's something that we can be confident in when we're prototyping. The only thing you need to worry about is that it's flat. So you learn to be pretty clever. So this is we ended up designing an 80-20 rig, which is like extruded aluminum parts, bolted together, have a bunch of holes in it wherever you need it. Designed this in a day, got it out the door. So if you rely on the technology that you know you can trust, it allows you to stay focused on what your hard problem is. Like, spend your energy on the actual hard problem rather than on trying to be fancy with your tools. So next, your team. So we've spent a long time talking about people, talking about the people that we bring onto our team and our suppliers, but this isn't actually the totality of the Misty West team. We rely on a wide network of experts. We never believe that we are the experts. We are facilitators of knowledge, so to speak. We have a really good breadth, but not a lot of depth. And so we treat a network of experts, we try to treat them really well. We invite them in to speak. We try to connect them with opportunities as well, so that when we have a question about some part that this person has spent 20 years designing, we can ring them up and know that they will help us. People are pretty open about helping each other if you just ask nicely, right? So definitely, yeah, a network of experts is essential to this type of work because there is no substitute for experience. Next, time, and kind of related to time is money. It says time is money. And we call this contingency and fallback. Contingency and fallback. I mentioned earlier that we try to always communicate risk. So we kind of think through this mentality of anything that will go wrong, you know, anything that can go wrong, will go wrong. And so we have these kinds of conversations of like, okay, well, let's get this part, but if that doesn't work, let's fall back to this technique. And if that doesn't work, let's fall back to this technique. We try to plan in advance for expecting that things will go wrong. And another important aspect of expecting that things will go wrong is preserving modability in your tools. So absolutely, we can design a very precise, very tiny 8-layer PCB off the bat. We could do that. Our confidence in that being right the first time is pretty low though. So what we generally do is create what we call a big board prototype, where everything is broken out and we can solder parts directly onto it very easily in our own in-house lab. We try to preserve that ability to make changes on the fly for as long as we can in the design process, because we are planning for things to go wrong and things to go left in unexpected ways. This is a good example from Alpha Da Vinci. We don't like working with stainless if we can avoid it, because stainless steel is very expensive and very difficult to machine. We can't drill it in our in-house lab. But this was, so like the first time we made this part, we made it in aluminum. But when it came to the final product, we knew we had to make it in stainless because it had to be food safe. You can't make food safe aluminum without a coating, which is hard to get fast. But the other thing we knew about making a part like this is that suppliers have a tendency to miss side holes. This part needed to have a side hole. We didn't want it, but it had to be done. So as soon as the box came, I took it out for QC like that day, and sure enough, they missed their side hole. But because I expected that to happen, because I reviewed it the second it came in the door, I was able to get it sent out and repaired in time to meet our delivery. Ironically, we also sent this part overseas as a secondary contingency, and that came back. Spares. Never make one. The saying at Misty West is 2 is 1 and 1 is none. You never make just one of anything. And this is pretty common knowledge, but it's worth reviewing. Always order spares, especially for anything essential. If it can break, it'll break. So next, to review, if you expect that you will fail, again, failure is normal and okay. And if you expect that the most likely thing to happen is that you will fail, it won't catch you unprepared. So these are the resources that you should give your team if you want to solve a really hard problem. Technology, including like the tools that you can trust, a wide network of experts if you can get them, talk to people, get to know whoever you can, and make sure that you build in contingencies so you're not waiting 6 weeks for your revised parts to come back. Finally, talk about process. So these are a few hard-earned lessons that we've learned along the way that I'd like to now share with you so that if you're solving a hard problem, you can avoid it. The first is there's no bad ideas in brainstorming. We try at Misty West to really enforce what we call brainstorming without ego. When we brainstorm at the beginning of a project, we try to avoid bringing experts into that discussion. We try to have a room of people who are very practiced at making a lot of different things, but without expertise in the area that we're actually trying to do. So this helps us because people will, suggest things that have never been thought of before, and maybe they're ridiculous, but there's very little difference between a ridiculous idea and a breakthrough idea. We also use our sense of humor in brainstorming. Quite often when I enter a brainstorming session, I will, suggest something intentionally ludicrous so that other people don't feel afraid to suggest something that is borderline ludicrous, but maybe feasible. So brainstorming sessions without experts and without ego is you're not the first. So one of the worst things you can do when you're trying to create a breakthrough problem is if you have like a really cool idea, is believing, oh, I am the only person to ever think of this, the only person to ever attempt this. That is a good way to run into a lot of problems. So instead, you should be asking yourself continuously, who else faces this type of problem or a similar problem? And how did they solve it? Or what kind of barriers did they run into? So in order to do this, the first thing we usually do is go shopping, you know? Like, whenever a client comes to us with a problem, we want to have an understanding of like, what's on the market? What's the most common technology? Why is that the most common technology? What is top of the line? And if your client is asking you to do something that's above top of the line for what you can get off the shelf, you know, you're gonna have to build in some contingency. You're gonna have to be prepared that that's gonna be tough. We spend a lot of time on YouTube. YouTube is probably my favorite thing. Who here loves how it's made? Yeah, how it's made. I spend a lot of time, for example, like if I think about, I work a lot in fluidics for whatever reason, and I had a problem where I had to dispense something. So I looked throughout a lot of YouTube how it's made and bottle dispensers and like material conveyance, because this allows you to get access to a lot of specialty off-the-shelf equipment that you might not have thought of. And it's a huge shortcut in design. Next is teardowns. Love teardowns. Whenever we get a new product category, like we try to buy a few different devices that solve the problem in a few different ways and rip them apart just to see how they're put together. For example, this particular problem, we were trying to create better than market insulation. So we wanted to understand why polyurethane foam was the best insulation. Like you see it in pretty much every refrigerator, and we were like, why? And it turns out that for the cost, you can't beat polyurethane foam. It's amazing. You make this little sheet metal enclosure and you fill it with polyurethane foam. You don't even need to mount stuff. You just tape it in there and it gets, you know, it gets stuck in there. And so as we were doing this teardown, within 3 days, we realized why polyurethane, despite not being the best in terms of insulation properties, is in every refrigerator. So again, don't ever assume that you are the first person to have an idea. If every single person on the market is using a particular technology, there's usually a damn good reason, and it's in your best interest to figure that out. So number 3 is try not to reinvent the seal. So this kind of goes back to using your trusted tools. Don't solve the problem that's not your problem. Like focus on the really hard thing that you're trying to do. We were doing a waterproofed product, and so we did a couple of teardowns to see how people were doing sealing. And over and over and over again, we didn't find anything except O-ring seals. So this is this little piece of rubber that keeps water out. And there's a really good reason. O-rings are cheap as anything. Like they're just a little piece of plastic. They have hundreds of engineering hours behind it. You can get this exhaustive guide that tells you exactly how to design this O-ring seal groove perfectly every single time. So when you're facing a really difficult problem, go ahead and stand on the shoulders of all the generations that have come before you, and that'll, you know, allow you to achieve great things. Standing on the shoulders of those who came before will let you reach higher. Number 4 is don't break the laws. So I've been on the Simpsons. Because we are pushing the cutting edge, once again, we always go back to first principles and do kind of a gut check of if the client is asking us to create state-of-the-art refrigeration technology, state-of-the-art optics, is what they're asking for actually greater than what can be theoretically achieved? We want to understand how close we are to that theoretical limit, and that allows us to give a better barometer of what's possible. So this is simulation. We do a lot of simulation. So if there was a container, for example, with a cold body, what is the theoretical limit for insulation, and how close can we get? So knowing the theoretical limits will let you understand how close to the theoretical edge you are. And if you find out that you're actually pretty far away from the theoretical edge, it means that there might be a really clever way to get a lot better. So the last section, no, second to last section is fail fast. We try to fail quickly as we can. We try to make a prototype that we can push to failure as early in the development process as we can. And when you're making a complex assembly, something that has a couple of different moving parts, a couple of different elements, we try to prototype that independently. Because once you put everything together, things can work together in really weird ways, and it can take you a really long time to debug it. So we try to make things independent. This is an example from that waterproof enclosure that I was telling you about. Don't try to reinvent the seal. So we just made a box with some seals in it to make sure it would work. This one had 3 different sealing areas, and it had a weird recessed screen. The main thing that we wanted to test, that O-ring sealing equations would tell us, is whether if we 3D printed, if we made this out of Delrin, would those threads be strong enough to hold the seal down? This is primarily what we wanted to test. So we just made a box and threw it in a pool. And we understood at this point that we could put it to 5 meters, 10 meters, no problem. So we could have confidence that if our prototype was going to fail, at least it wasn't going to be getting all of our electronics wet. It would fail some other way. The next thing is test often. So this is a card reader for a product that we did. The card reader was going to be embedded in another mechanical system that had a latch and some other solenoids and stuff. And we basically just wanted to test, like, can we put a card here and make the solenoid go? And by testing this independently, what we learned is that 1 out of every 100 times the solenoid would stick. And we couldn't have figured that out unless we kept testing this over and over and over again early on. And because we found that early on, we were able to build in contingencies and fail-safes in our process so that if it got stuck, or how could we avoid it from getting stuck. Next is data sheets lie. Especially if you are pushing something to the edge of its performance. This is an example of a battery. We had to put a battery in an Arctic location. That was our farm in Alaska. We had to get this thing really, really cold, and it had to send a high current very suddenly, and it had to last like 6 months. So when you look at the data sheets, there were plenty of batteries that were capable of doing this. So we bought a few and immediately threw them in the freezer and tested them. And what we found is that their expected life was way, way lower, like 50% lower than what it was actually advertised on the data sheet, because it was at that temperature extreme. Usually when someone is creating a data sheet, a lot of the areas are theoretical. They take the middle, most common area and kind of extrapolate out. So if you are pushing the edge, always test it. Don't trust the data sheet necessarily. Get real data. So again, this is the difference between theory and real life. This is Phil's project, right? So we were doing a door sensor. And as you can see, you can mimic a door pretty easily, but there's no real substitute for building a door. It cost us like $100. And we just put it in the path where all the engineers are going up to the 2nd floor. So we had real data that we could work with and start to understand those weird edge cases and start to build it out. So yeah, you learn 10 times faster by failing than you do by creating a prototype that you're confident will succeed. So build a prototype that you're sure will fail. Next is iterate. This is when you have everything together as soon as possible, put it together, because this will expose the complexity. So as I mentioned, when you put things together, they start to fail in really weird ways. And unfortunately, you can't really predict how that's going to happen until you put it together. But you will learn something. You can see that these prototypes are all slightly different. Every single time we put it together, we learned a ton, and we were able to make it better every single time. So building something is the fastest way to build it better, and this is the best way to expose complex interactions. And last is, there's going to be things you cannot expect. So when you encounter something you didn't expect, challenge your base assumptions. Challenge what couldn't possibly be the answer. So for this example, this was a power supply. We built this board, we built the entire custom board, put the components on, and we thought for sure the problem was going to be somewhere in the process that we designed. It couldn't possibly be this off-the-shelf power supply from a reputable supplier. But when we challenged that assumption and just wired directly around the power supply, the whole rest of the circuit worked fine. We had to challenge that assumption that it couldn't be that part. And again, this is kind of going back to data sheets lies. Sometimes you find something really, really, really deep in the data sheet. If some weird setting that you're going to trip. So don't assume that because you expect it to work a certain way, it's going to work that way. You kind of have to do a little digging, especially if it's core to what you're doing. So challenge your base assumptions. You know what they say about assumptions. So, final review. There's no bad ideas in brainstorming. Go ahead and suggest something ridiculous. You might find something surprising along the way. Never assume that you're the only one trying to do this. Don't try to reinvent the seal. Don't break the law. Fail fast. Iterate. Keep doing it over and over again, and expect that you can. Expect the unexpected. So that's it. Those are the 4 elements that I consider part of MistyWest's success in solving hard problems over and over and over again. But we'd love to hear about your hard problem and how we can help you. So, last but not least, these are our corgis. This is Mila, which is really great. And this is Steve, the dog. I borrowed a trick from my artist friend, Shinian Kaur, who made these pins. And every time you ask me a question, I will post another picture of the dog.
Oh my god.
So, go ahead and ask me questions.